All right, welcome everyone. Class is in session. Today we're going to dig into a rule in physics that is just so fundamental. I mean, it explains everything from an astronaut just floating out in space to a supercar tearing down the highway. Yep, we're talking about Newton's first law, the real secret of motion.
So, let's start with a puzzle. You ever wonder why a book on a table just sits there, perfectly still, but a hockey puck on ice seems to glide on and on forever? They seem like total opposites, don't they? Well, the secret link between them is one single, really powerful idea: force. And once you get that, you've got the key to everything else we're going to talk about today.
Okay, so before we can really jump into Newton's law, we need to get one crucial tool into our toolkit. It's called the resultant force. Just think of it like the final score, you know? It's what decides if something's going to move or stop or just stay put. Seriously, once you get this, the rest is a piece of cake.
Okay, picture this. A huge game of tug-of-war. You've got teams pulling in all sorts of directions. The resultant force? Well, that's just the final outcome. It's the one single force that tells you which team won, and by exactly how much. It's the net effect, the total result of that whole battle.
And finding it is actually super easy. It's just a simple three-step process. First, you identify all the forces going in one direction. Second, you do the exact same thing for all the forces going in the opposite direction. And then for step 3, you just subtract the smaller number from the bigger one. That's it. The answer you get tells you who won that tug of war and by how much.
All right, so now that we've got resultant force down, we can tackle the main event, Newton's first law of motion. The whole thing, the entire law, really just boils down to one simple question. What happens when that resultant force is 0? This right here, this is the absolute core of the law. And remember, velocity isn't just how fast you're going, it's your speed and your direction. So what this law is really telling us is that, well, objects are kind of lazy. They just want to keep doing whatever they're already doing. And they'll do it forever unless some outside resultant force comes along and messes things up.
So this law really has two sides to it, and they're both super important. On the one hand, if an object is stationary, like a book on your desk, it's going to stay stationary. That's the part we all kind of get intuitively. But here's the part that can feel a little weird. If an object is already moving, like that hockey puck on ice, it's going to keep moving in a straight line at that same speed forever, as long as those forces on it stay balanced.
Okay, let's break this down and make it really clear with our first case study, stationary objects. We're going to start with something super simple, a box that's just not going anywhere. All right, so just picture a regular old box sitting on the floor. It's not moving, right? It's stationary. That means its velocity is 0. And according to Newton's law, if the velocity is 0, what does the resultant force have to be? That's right, it's got to be 0 too.
Okay, now let's imagine two people start pushing on this box. One person is pushing to the right with 50 newtons of force, and another person is pushing to the left with the exact same amount of force, 50 newtons.
So let's do the calculation. We've got 50 newtons pushing one way, and we subtract the 50 newtons pushing the other way. And what does that give us? A big ol' 0. The forces are perfectly, totally balanced.
And there you have it. That's the law in action. The resultant force is 0, so there is no change in velocity. The box was already just sitting there, so it keeps just sitting there. Simple as that.
Okay, now for the part that sometimes trips people up a little. But trust me, it follows the exact same rule. What about things that are already moving? This is where the law gets really, really interesting.
Let's look at our second case study, a car driving down the road at a constant speed. And that's the magic word right there, constant. It's not speeding up, it's not slowing down, it's not turning a corner. In other words, its velocity is staying exactly the same.
So to really get what's going on, we have to look at the two main forces at play here. First, you've got the engine, which creates a driving force that pushes the car forward. But at the same time, you've got resistive forces, things like air resistance and friction from the road, and they're pushing backward, trying to slow the car down. Now, since the car's velocity isn't changing, what does Newton's first law tell us that resultant force has to be? It has to be 0. And what does that mean? It means the forward push from the engine has to be perfectly balanced by the backward drag from all that resistance. They are exactly equal. They completely cancel each other out.
Okay, so you've seen the law in action. You think you're ready to try a couple on your own? Let's do a quick little pop quiz and see if you've really got this down.
All right, first question. A car's engine is providing 2,000 newtons of force forward.
At the same time, air and road resistance are pushing back with a total of 2,000 newtons. So, first step, what's the resultant force? And second, what happens to the car's velocity? Go on, take a second to think about it.
That's it, you got it. 2,000 newtons forward minus 2,000 newtons backward equals a resultant force of 0. And a 0 resultant force means no change in velocity. The car just keeps on cruising at a constant speed. Perfect. Okay, one more for you. A rocket is sitting perfectly still on the launch pad. All of a sudden, there's a resultant force of 50 newtons pushing it straight up. What's going to happen? Exactly. Because there is a resultant force. It's not 0 this time. The velocity has to change. The rocket was stationary, so any change means it's got to start moving. It accelerates upwards. Well done. So let's wrap this up. Here's the big takeaway. The resultant force is really the master key to understanding motion. If you figure it out and it's 0, the velocity stays the same. Period. If it's anything other than 0, the velocity has to change. It'll speed up, slow down, or change direction. It really is that simple. And that, my friends, is Newton's first law. But it does leave us with a pretty cool question to chew on for next time. Think about it. A ball that you've thrown up into the air is obviously slowing down as it flies up, so the forces on it can't be balanced, right? So what's the unbalanced force that's acting on it? We'll get into that next time. Thanks for joining me.